Hello guys, welcome back to the Reaction Zone. In today's lesson, we're going to solve this question, making use of Graham's law of diffusion. And the question goes thus. Two flasks A and B of uniform size are joined by a tube of 40 centimeter long. A contains ammonia and B contains HCl. Calculate the distance from side A, where whitish fumes first appear, when both flasks are opened and closed simultaneously. To solve this problem, the first thing to do is to represent the information that we've been given using a diagram. The first part of the question says that there are two flasks, A and B. So let this represent the first flask, and this represents the second flask. And we also told that they are joined by a tube of 40 centimeter long. So this is the tube that joins both of them. This is the first flask. This is the second one. This is A, and this is B. While this represents the tube. So the tube is 40 centimeter long, meaning that the distance from here to here is 40 centimeters. A contains ammonia, meaning that what you have in this flask is ammonia. And B contains HCl, meaning that what you have in this other flask here is HCl. And you're told to calculate the distance from side A, where whitish fumes first appear, when both flasks are opened and closed simultaneously. When both flasks are opened, what happens is this. Ammonia will flow into this tube as well as hydrogen chloride. The point where they meet, let us call that point O. The point where these two gases meet is the point where the whitish fumes will first appear. Because at that point, ammonia will react with HCl. And when ammonia reacts with HCl, the product formed is ammonium chloride, which gives off whitish fumes. Now the question is telling us to find the distance from side A, where whitish fumes first appear. We already know that the point O is the point where these two gases will first of all meet, and that is also the point where the whitish fumes will first appear. So let's make some assumptions. Let O represent the point where whitish fumes first appear. The question is telling us to find the distance of the side A from where the whitish fumes first appear. If this is A, the flask, and O is the point where the whitish fumes first appear, it means that the question is telling us to find this particular distance here. This particular distance from here to this point. So we make another assumption. Let the distance of A from O be X centimeters. So it means that the distance from this point to this point is X centimeters. If this is the case, it therefore means that the distance of O from B will be 40 minus X centimeters. So we have to make another assumption that the distance O from B is equal to 40 minus x centimeters. And when you add these two values together, it will give you about 40 centimeters. Having said this, it's important for us to know at this point that the rate of diffusion of a gas, is directly proportional to the distance traveled by the gas. So, for this question, we'll be representing the rate of diffusion of ammonia as well as the rate of diffusion of HCl with the distance traveled by each of these gases from the flask to the point O. So, what that obviously means is that the rate of diffusion of ammonia, which is in flask A, will correspond to this distance, which is x centimeters. And the rate of diffusion of HCl, which corresponds to the distance of O from B, is 40 minus x centimeters. The next thing is to determine the molar mass of these two gases. The molar mass of NH3 is 14 for nitrogen plus 1 times 3 for hydrogen, giving us a total of 17 grams per mole. The molar mass of HCl is going to be equal to 1 for hydrogen plus 35.5 for chlorine, giving us a total of 36.5 grams per mole. Now that we know the molar masses of the two gases, and we have represented the rate of diffusion of the two gases by the distance they travel from their respective flasks to the point where the whitish fumes first appear, we can now compare their rate of diffusion. So, rate of diffusion of ammonia over rate of diffusion of HCl is equal to the square root of the molecular mass or molar mass of HCl over the molar mass of ammonia. The rate of diffusion of ammonia is represented by x. That of HCl is represented by 40 minus x will be equal to root 36.5 over 17. What is here can also be represented as x over 40 minus x is equal to root 36.5 over root 17. The right hand side of this equation can also be represented as this using the division law of salts. So the next thing is to find square root of 36.5. Root 36.5 is going to give us 6.04. So x over 40 minus x is equal to 6.04. And root 17 is going to give us 4.12. So when we simplify this, we have this. The answer we're looking for is actually the value of x. So the next thing to do is to cross multiply. X times 4.12 is going to be equal to 6.04 times 40 minus x. So this becomes 4.12x This 6.04 is not just multiplying 40, but the whole of 40 minus x. So we represent it as 6.04 into bracket 40 minus x. So 4.12x is equal to 6.04 times 40. 6.04 times 40 is equal to 241.6 minus 6.04x. So the next thing is to collect like terms. Bring minus 6.04x to the left-hand side of this equation so it becomes positive. So this is 4.12x plus 6.04x will be equal to 241.6. 4.12 plus 6.04 to give us 10.16x is equal to 241.6. So making x the subject of this expression, x becomes 241.6 over 10.16. 241.6 divided by 10.16. The value of x is 23.77 centimeters. So, what this means is that the distance of side A from where the whitish cubes first appear, which is point O, is 23.77 centimeters. So that the distance of A from where whitish cubes first appeared is equal to 23.77 centimeters. Thank you for watching and see you some other time.